Working once again, let me know. And let me just tweet. I forgot to tweet that I am live. Oops, stream is live. And I'll put up the link again just to make sure. And I'll keep talking loudly to myself just to make sure that everybody can hear me. Okay, I am very happy to be here again. And it's important that we discuss the basics of the language. No chocolate powder this time. So, last week I saw two issues with viewers had. One of them was, many of the viewers come from a C and C++ background, especially since Jai is trying to be a decent and robust C++ replacement. They were having a little bit of confusion on how things work at a syntax level and some of the semantics. So it didn't occur to me that there are going to be some viewers who just haven't gotten around the syntax yet. So I'm going to show a little bit of the syntax today, and it's going to be a little different from John's demos in that I am specifically showing almost like C and C++ equivalents, and how do they look on Jai? Like specifically this thing, this is how it looks on C++ usually, this is how it looks on Jai, yada yada yada. And then I'll be showing unique features about the language. I'm not sure if we'll have time to cover all everything Jai has to offer in one stream. So I'll start with workspaces, which is like the one thing that I would say is a very defining feature of Jai. There's a lot more, but this is like a major feature. So we're going to start with that right away. And then I'm going to keep showing other unique features of the language that you guys need to know in order for you to be able to follow all of the programming projects on these streams, right? And after that, we will continue with the project, basically. All right, so let's get started. Thank you for joining me, by the way. Okay, so real quick, variables and pointers, how would that look on the language? So let me bring up some of my screens over here. I have two monitors, so you're probably not seeing the other one. Basically, where's my console? Da, 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 da. That is not it. This is it. Okay. So let's just quickly start with variables and pointers, right? Variables should be the first thing, or I would just call them identifiers, right? So identifiers.jai. And let's quickly import print, just in case we need to print stuff. And then our main procedure, right? Main procedure. We usually say procedure instead of function, unless the function is pure. Put on some quick notes as well. All right, so usually in C and C++, you will have an identifier be like this. So int high score, right? And then you're good to go. That's not how it works on Jai. On Jai, all we do is high score. Basically, identifiers in Jai start with a letter or an underscore, just like C and C++. And it is followed by like one or more, alphanumeric characters. That's all good. So that's exactly like C and C++, except we declare the identifier followed by a colon and its type, right? Let's do another one. So age, int and reading interest. We'll make that a float. Are you 100% interested in reading code? Let's call that code reading interest, right? If you care about spacing, you can do that. In fact, let's just quickly compile this. So let me make sure it works. That doesn't work because that's C and C++ code. So get rid of that. Let's do it again. And I'm sure this is slightly boring for those who have followed all of John's demos, but it'll get interesting once we get to workspaces, and that won't take too long, right? So that worked. It compiled. Another thing that compiles is backslash identifiers. So let's say you want to align high score and age to be aligned with the variable that has the longest name, in this case, code reading interest. Then there are multiple ways to do it, but you can do it like this. See that I added a backslash? That will compile no problem, right? I don't use it very often because for searching on Vim, it sort of breaks my flow, but you can do that if you want to. Variables are initialized to default values, right? That's very different from C and C++. So high score, let's add a string too. Hold on. Hello sailor equals hello sailor. We'll make that a string. Okay. Hello sailor string. And I'm supposed to show default value, so don't do that. Okay. So int will have default value of 0, age will have a default value of 0, this will have 0.0, and this will have empty string, right? So they always have values by default, and we can print those. And here's another cool thing of the language. Notice how in my print statements, I don't format it in C and C++ as you would do in C and C++, right? So for high score, you would say a D because it's an integer. Code reading interest is an F because it's a float, and then an S here. You don't need any of that, right? Print automatically knows the type of the arguments that you pass it, and it'll automatically detect that and print it, no problem, right? So, oops. And let's run it. There you go. And string is just empty, so you're not going to see that there. All right. That is very simple. Let's move on to arrays, but let me see if anybody has any questions. It's super simple though. Yeah, I don't be business. I don't see myself splitting the identifier myself. There has been talks about whether or not we'll keep it. So. Okay, interesting questions that I'll get to very soon. The one that I don't understand is from Pyth. No, he's asking, he or she is asking, does it matter where the definition happens regarding initialization? Like, give me an example and we'll put it up there and we'll compile it if you want. Okay. So let's move on. The next thing is arrays, right? So let's just go, let's keep, first of all, let's make the file slightly bigger in font. There you go. Actually, before we even get to arrays, you could uninitialize the values, right? So you could say this, It's basically flipped. The notion of initializing values is that it happens by default, but if you don't want to initialize them, which is a little dangerous, but it's a good optimization technique, then you just do that for all of them, right? Gosh darn it, Abner, you gotta put the extension in. And now we get garbage values, right? Yep, garbage values. We were lucky with the string and with the floating point value, but don't count on it. Okay, now we can go to arrays. Okay, so arrays, man, they're very interesting. So you can have fixed size arrays, and the way that works, in C and C++, I don't even remember. But let's have a high scores array in C and C++. How does that look? Is it like this? Right? And it's also uninitialized. Unless you decide to initialize it in C, at least you can do this. I think in C++ you have to get rid of the 0. I think. Anyway, so that's how it looks in C and C++. If you want to do it on Jai, it's still basically the same as if you would declare a variable, a simple int, but right before the int type, you say 100, right? So and it flows very naturally, right? So you can say high scores. Okay, that's the identifier. How many of it do you have? If you have nothing, just 1, you just type in the type. But if you have a lot, then you just specify how many and then how many of what integer, right? That is very simple. Now, let's say top 100 scores elements are initialized to 0. Remember, all of these are initialized to 0. And that is supposed to compile, right? Now, what if you don't want to initialize them? Well, the same thing as you did with variables earlier, simple variables. That'll work. And you're good to go, right? Now, what's useful about this is that the compiler knows the size at runtime, right? So this is a fixed size array. It means that if you try to pass this array to a procedure that takes in a different sized array, then you're gonna get compiler errors, blah, 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 right? All right, let's move on. Dynamic arrays are simple. All you have to do is say, I don't know the size, and you're good to go, right? That's it. Yeah. And it doesn't matter whether or not it's fixed size or dynamic. You will always have access to the element count, right? So let me show you that. Let's import the array module. In my project, Blobman and all the games use arrays a lot, so you really want to know this. So I just imported the array module, which means now you have access to all the array procedures or functions. So one of them could be array add, and then you pass in a pointer to the high scores array. Oh man, yes, you guys are gonna suffer with pointer for a little bit because I haven't explained it yet. But this star means you're passing the address of high scores. You're not dereferencing high scores. No. You're just passing the address, okay? You'll see why this makes sense in a second. Okay, so what are a few high scores? Let's see, 50, 80, and 100, right? Good to go. And now we can say print, we have percent scores and high scores, right? And all we need to do is say high scores, and then we access count. And that's it. Let's try it out. I made a mistake somewhere. Thankfully, Jai's errors are simple. Oh, I see. Yeah, wow, that was a rookie mistake. So dynamic, actually, you want to pass in these two dots, right? That is what makes it dynamic. I was actually trying to show what I would call, we don't have an official name for this yet. I'm calling it array view, but you can call it maybe array slice. Name is temporary. We don't know what to call it yet, which is what I was trying to do. So let me uncomment this. Okay. Int. All right. So it doesn't matter if it's a fixed size array, dynamic array, or high scores, you're always going to have access to count, right? And before I show you array views, I definitely want to compile this for you guys. Wow. There you go. There. We have 3 scores and high scores, right? Because we added them here. So that's all good. Sorry, you gotta put these 2 dots. Okay, that's what makes it dynamic. The compiler will know it's dynamic that way. Now, let's say you want to have an array that doesn't care whether the assignment that you give it is dynamic or static. In other words, imagine you have a procedure called print array count, right? And you wanted to take any array. It doesn't matter if the array that you take is static, fixed size, right? Or if it's dynamic. You want to print the count of either of those arrays, of either of those types of arrays. So you can just say array and then this, which makes it an array view or a slice. Again, don't have an official name for that yet. Slice can mean is an overloaded term, so we're not sure. But all it means is, hey, I don't care if you're giving me a dynamic array or if you're giving me a static array, right? And then you can just say print array count is boom, right? Array.count. And you can make this polymorphic so like you can take any type, but we're not discussing that at the moment. Okay, so let's do it. Let's first pass in a fixed size array. Okay, so let's comment out this. Boom, boom, boom. Okay, and we're gonna call print array count array, or sorry, high scores. And that should work, unless I lied to you, right? Array count 100. Perfect. Why? Because we declared a 100 element array. Okay, now we're gonna comment this out. And we're gonna print it down here. Now this array is completely different. It's dynamic, right? We compile it again, and now it shouldn't give us 100. It should give us something else. 3, right? So that's basically why you would use it. I mean, this has all the features of a regular array. It won't know the size. It won't know the size at compile time, and you wouldn't pass it to functions or procedures that would take dynamic arrays, right? But everything else would work just fine. Like you can index things and it's all good. All right, questions? Any questions from the chat? Mega green lighting. Can you explain the underlying data structures for the different kinds of arrays? I'm assuming an array view has a pointer and a length. Yeah, so I'm trying to stick to the very basics, but I can definitely tell you that they do have a pointer to the data and length, right? And so you can access that directly. So you could say, all right, I wonder if I should just clear the buffer, technically, right? Let's clear it. There you go. So you could say high scores int, and that'll get you high scores.data, right, which you can store. So you can say, I forget exactly which type it is. I don't want to lie to you, but I think it's like this. Pointer to, you know, U8 bytes. And then you can say count equals high score, that's count, right? So you definitely have at least those two elements. Any other questions? Somebody asked what would happen if I call array add with this type of array. Well, you already saw what happened. It wasn't dynamic, so. Strings. Strings are also having data and a length and a count, right? So we can talk about strings actually because we haven't done that. So again, hello sailor. This time I'm gonna say it's hello sailor. And so you can get how much you have there. Let's just do it here. Yeah, my auto formatting is a little broken. I updated my vimrc at some point. I'm not sure what's going on. Okay, so we can say hello sailor count, right? We just say hello sailor. And then hello sailor data, right? You can say hello sailor.data and whoops, count. Okay? It's exactly the same access as an array. And let's print. Right? So here's the memory address of the string, and here's the count. Right? It's just a different struct, right? Okay, so let's keep going because I don't want to waste too much time. I definitely want to get to the fun parts. But I definitely want viewers to definitely, like, I keep saying definitely, for them to know the basics. So as long as there aren't any questions of the basics, I will continue. How are the strings allocated? Do they use the allocated from the context struct? That's not, I wouldn't call that super basic, but yes. In fact, anything that you allocate in a program uses the context allocator, right? At any point in time. which means like if you override the allocator to use your own memory allocator, the entire program and all the libraries that you call actually would potentially be using just your allocator, which is a lot of control that you get over memory allocation. It's also a lot of responsibility, right? Okay. Here we go. So I think that's everything about variables, right? So let's move on. Pointers. Ah, boy. All the debates that you get from pointers, right? I think Jai's approach is reasonable. Let's do a pointers.jai. We'll import print in case we need it. Okay. So pointers are pointers. It doesn't matter if it's C, C++, or if it's Senjai. If it's a reasonable pointer in that all it does is point to somewhere in memory, right? And that's all it's going to be always, right? So pointers are declared to hold the memory address of a piece of data, right? So let's say we have, let's see, somebody from the chat. bbusiness was there earlier. So bbusiness age is an int, right? And we're going to set it to, let's say he's 30. He's definitely not 30 years old, but now, what if we want to take a pointer to bbusiness age? Well, bbusiness age pointer asterisk int. All right, let's pause there. So there you go. The asterisk indicates that we're declaring a pointer to int, right? And we could initialize it right there, but let's initialize it down here just to show that we can. bbusiness age pointer equals. Now, pointers only hold memory addresses, right? So I got to store the address of bbusiness age. So what do? Well, you say bbusiness age, right? But then you precede it with the pointer symbol. And now you're taking the address, right? That's it. So let's do a few prints, okay? So age value is just age, which will be 30. Age address. So if you like take bbusiness's age address right away, then you can just say star bbusiness age, right? And that'll give you the address of bbusiness age. Because you're not using it in a declaration of a variable, right? So the star takes on a different meaning. It just means the address of something, right? And then we're going to print the same address through the pointer, right? So in this case, we just print the pointer, right? And so, you're printing a variable like any other, but what's the value of this variable? The value is an address, right? And the address will be the value of the memory address of bbusiness age. So these two are equal. Hopefully that makes sense. Undeclared identifier? Did I make a mistake? Ah, hold on. Your username is a little bit confusing. So I mixed up the S and the I up here. Okay, let's try that again. Really? Oh, because it has to be bbusiness age. Man, you let me down, bbusiness. You let me down. Or did I let you down? Right? There you go. That's it. One last thing though. What if you want to dereference bbusiness? What happens there? age value. So if you want to get bbusiness's age, just like we did in this first line, but through the pointer, then we gotta dereference it. And all you need to do is say this, and then say bbusiness age pointer. So these two symbols are the same as dereferencing, or that's what it means. It means to dereference bbusiness, right? So that'll give me 30 down there. Boom. So you only have two symbols to care about in Jai. You know how in C++ you have the asterisk to declare and dereference a pointer. You have the ampersand to pass in the address of a variable, and then you have and that would be it actually. But for us, the way we're doing it is we don't have an ampersand, right? We just have the asterisk here. It's always used to declare a pointer or to pass an address of something. And then dereferencing is like a completely different operation. And that's why it has its own syntax right there. As always, in this language, there may or may not be changes in the syntax. So I think the star is pretty much going to stay, as far as I can tell. That's not going to change. But this right here may or may not change, just so you know. The point is that we've made sure that this is a little nicer, passing a pointer and declaring a pointer, and then dereferencing a pointer. Those categories are nicely conceptually distinguished, but that's just my opinion. Questions? Oh boy, I knew this stuff always gives you a little bit of religious fervor. Somebody's asking for me to increase the font size. Okay. Well, we're already done with pointers, so let's do a new. Let's do a new section. Okay. Procedures are super easy. So let's do procedures. Let's set the font a little bigger for James Whitman and for everybody else, of course. Okay. So you know how in C and C++ you would say something like void print name, and then you take in a name, which is like a const char name, and then you have your code. In Jai, as always, just like variables, the identifiers will go first. So it's print name, and then you do 2 colons, and then in parentheses you're gonna pass in all the parameters. So the parameter list goes in here. So name, and again, it's just a variable. So the identifier goes first. Then you say what type it is, string. And then you can say, hey, arrow, because I'm going to tell you what you return, and you return nothing. All right. So this is the Jai way. Right? And of course, you can omit the arrow if the return type is void. Why do you need to specify it? Right? So that'll do. Okay. And then let's do print name, or let's do print age. Right? It returns nothing, so we're good to go. And if we like print the name and the age, name, string, age. So now I'm showing you, like I said, you can do void to be more explicit. This is how you do multiple variable declarations, right? So that's cool. That's very cool. Now let's say you want to get the name and age, right? So get name, and then it returns a string, right? And you can say return James Whitman, right? You can say, hey, get the age of James Whitman, because bBusiness let me down earlier. So I don't know how old he is, so let's just say 31. Okay. And let's say we want to return both the name and the age, right? Well, you separate it by comma. So string and then int, and you're good to go. Return James Whitman, 31. And that's easier for me, so I'm going to get rid of this thing up here. Simple enough. Now you may be asking, how do you capture those two return values, right? So if I'm calling it from main, and I want to get the name and the age, then I just declare enough variables for them to be catched. So name is a string, and age is an int, right? And so you can say name, comma, age, and then that'll get you what you need, right? You're good to go. Now let's say you want to avoid having to declare them first. Well, thankfully, you can do a colon here. And what this means is, hey, declare both name and age and assign them the values given by get name and age. And you can do this a lot. So like, let's say, I don't know. Let's go back to bBusiness age equals get bBusiness age, right? And let's define that. Return age, which will be 30, right? So the compiler will automatically infer the type of bBusiness age by figuring out the type of the return value here, and it'll be the same case here. It's just happening for multiple variables. So that's it. There's a lot more to procedures, of course, right? There's like default arguments and all of that jazz, but we'll present that in the future because we want to keep going quickly. Yes, so Lucas asking, hey, can you do A, B, and then int to declare two integers? And the answer is yes. So let's compile this. There you go. Just for the sake of asking, can you declare only one of the return values? Dan Zaidan. Yeah, you can. I mean, let's see. You can ask for the first return value, right? And then ignore the second. I don't think we have a way to specify which return value you want. And there were reasons, philosophical reasons for that. So you just have to reorder. You have to order your return types by importance, right? And the way you can do that actually is to say, let me give you an example of what I'm trying to say. So get file handle, right? So let's pretend file name. Let's pretend you have, actually let's call it open file. And let's clear this file so it looks a little easier to manage. There we go. So we have an open file procedure, right? It takes in a string, which will be the file name. And it's going to return some handle, so file handle type, right? But let's say you also want to return whether or not it succeeded in opening it, right? So you can just say bool for true or false, whether or not it was successful, right? And so now we say file handle, and we say, hey, file equals open file and done Cydon secrets.txt, right? And that'll work. And I'm ignoring the second value. But if you don't want it to be ignored, you could pass in the must directive to it, and this will force the compiler to error out because you didn't like restore the second return value, right? So I hope that makes sense. So you can ignore, if you want to, the second return value. If you don't want it to be ignored, you use the must directive, right? And I guess we should show you that. First, let's do it normally. Jai procedures.jai. This should work because we're just ignoring the second return value. Oh, there is no such thing as a... Okay, so let's alias it. Let's just call it, it's some int of some kind. Right? So that worked. We got a warning because we didn't return anything in open file, but it's all good. So that worked. I can actually ignore everything, right? Let's ignore everything. It worked. But now let's say, you know what? Don't ignore bool. So we just say must. And now look at this. Here's the error. Return value 2 is being ignored, which is disallowed by must. Okay. Now as an API designer, this is useful, right? Because if you're if file handle is some memory allocated thing, then you definitely want the user to take that in because then they'll leak memory. But if you use it all the time, then you're giving your users a lot of trouble, right? And they can just use metaprogramming to ignore your must directives. So, Organumkin, is there a limit on the number of things you can return from a procedure? No. I will be drafting the language spec sometime soon because the language is just about ready for a beta. So once I start writing the spec, I'm gonna have to say, okay, an implementation of the Jai compiler only needs to be able to return up to 100 values, right? And of course, there's ABI limitations that you want to take into consideration and all of that, and you don't want to complicate things. But those like minimum guarantees will be in the spec. So the spec will determine what the maximum upper bound or lower bound is of stuff like that. Like how many procedures is a Jai compiler allowed to compile before it complains? Like if your program has 1 billion procedures, right? Should the compiler be forced to compile that much, right? So we have to decide those things. Library and macro features, yeah. John is working on modules and macros. If you want to know the order of things, basically, the website will get released some point soon. Then we'll have John's demo on some new features that he's doing, and then the closed beta will probably happen. Again, I'm not John. He'll probably change things around or something, but for now, that's what we have planned. So. Okay, I got another question about memory allocation. That'll definitely be covered in this stream. We're trying to stick to the basics, and since Jai has a lot of powerful memory allocation mechanisms, I don't want to touch on it just yet. If your global string is just literal, it will just go into the initialized data section, right? And if your array is initialized, although I see your question, right? Because we have default values and all of that stuff. So, but yeah, string literals will always be like the same. And in the future, I'll talk to you about memory allocation. Okay, so moving on. Those are the basics of procedures. One last thing I want to show you is that you can give identifiers to these return values. And even though you can't reference a return value from code, right? Like you wouldn't be able to use it, especially if it's a procedure scope, right? But you can definitely say like my file, right? And then success, right? And that'll work. And now your return types have an identifier, which is a good way of like telling people, hey, this is what I would call my return value. It's a way of documenting code without using comments, right? So that's pretty cool. I use it quite a bit actually. You're gonna see it in my Blobman code once we get back to the project. And you can put parentheses around this, right, to make it a little cleaner. And that should compile just fine. Boom, right? Dan Zaidan is, okay, he's asking whether this line of code is the same as this line of code. This. Thankfully, we can just compile and we can find out. Haha, you are correct. Much in the same way, so imagine that I have a constant, right? Oops. Pi 3.14, right? It worked. This is just a shorthand for basically, you know, this, right? Good to go. All right, I don't see any other specific questions, I think. So that's all I have to say about procedures for now. Yeah. What's next? Man, I don't think we're gonna get to workspaces today, but this is important. Procedures, yeah, we just went through that. Structs, enums, and unions, that'll be super simple. So, because I'm not gonna go into detail about them. Structs, enums, and unions. Let's see. So an entity, let's just call it a player struct, right? This is how it will look. String, health, and int, and you're good to go, right? We can have an enum. Look at that. And then we can say a character, whether the entity is a monster, or whether the entity is a healer, something like that, right? And now our player struct can take a base of type entity. And that should all just work. And then a union, I think I did this on the last stream, but unions basically share a common storage space, right? Which means it'll be the size of the largest type in the union, and then it'll be shared across all the fields, which means you can only access one field at a time. All right, so wine, a string, wine percentage, like alcohol percentage, right? A float, and you can only access one of the two, just one of the two, right? This would start at 0, and then it'll keep increasing. But you can definitely just say 1 here, and then it'll start from there, right? Or an 8 or a 9. And you'll notice this is actually pretty cool. Let's give this each different values. If you want to compile, let's just quickly compile this. It worked. Let's say you don't want to care about the entity enum anymore, right? Then you can get rid of them, but the values are now constants if you want to. And that worked, right? Can I have an anonymous struct inside a union? Yes. You can have anonymous structs inside, anonymous structs inside, anonymous struct inside a union that's inside an anonymous struct that's inside who knows what else, right? Okay. What's next? Simple statements. What are simple statements? Yes, the if statement and the switch statement. We'll call this file statements, right? We'll set the size a little bigger. Is Jai released to some extent, or do you have closed beta access? I work for John full time. I'm on the compiler team. Okay, so here, if statements are similar to in C and C++, except, so let's say we have a value, right? So Boolean value now I'm not the designer of the language. That will always be John. I'm just on the compiler team. No, I hope I didn't sound rude or anything, right? Yeah, no problem. Happy to answer questions. Okay, so Boolean value. Yeah, so if Boolean value equals true, right? We can have an open bracket and say it's true. Now, of course, you can ignore this because Boolean value is a Boolean. So you can just say if Boolean value, print it's true, right? Notice we're not using parentheses around the expression. We don't have to do that, right? Just like in C and C++, we can ignore the brackets if the conditional block to execute is just one line of instruction, like print, right? And if we want, we can say then. Then doesn't have anything special about it. It just helps you read the code a little better. But for the compiler, you can have then or you can ignore then. It doesn't matter. Right? I do a lot of this though. Right? I do that quite a bit. So, yeah. Let's move on. Precision of language matters. Yes, one instruction. Okay. And of course, you know, you can chain it. So else if blah, else if blah, right? And then an else, and you're good to go. And then you can ignore the else ifs and just have an if else, and you're good to go as well. And then you can have ifs inside. You know, this is just a regular block of code, so whatever. Let's finish up with the switch statements, and I think we'll have all the basics covered, at least for you to understand all the projects we're going to do on this train, right? Let's see, what does the chat say? How do you compare strings? You can definitely compare them directly. So hello, who was the user? Luca? Okay. Asking questions, good questions. Let's just keep it simple. Or let's just try and call it user, right? My gosh, I have to fix the formatting on Vim. I'm getting annoyed. If user is equal to Sasluka, then print hi. Right? Make sense? And this is a compiler feature, right? So earlier I said that user is a string and it's a struct that has a data pointer and a count. The compiler knows also about the string struct in a way that if it sees a comparison between these two, it'll know that user is a string and it'll just do the comparison properly. And this will work, right? Boom. Now I'm threatening people on Twitch. I'm sure my mom will be proud. Alrighty. Let's get to the switch statement, right? So the switch statement is an extension of the if statement, if you want to look at it that way, right? So it's basically like, hey, if variable is equal to, and then you open up a block. So this is how a switch statement starts. It's say, okay, you have a simple variable, and it can be anything. It can be an integer. It can be an enum. It can be a boolean. It can be a string. It can even be a float, though I don't recommend floats. Don't switch on a float, people, please, even though you can. Use your power for good. So if variable is equal to something, right? So you can have a multiple case statements. So a literal here, then you do a semicolon, and then anything after this is your scope. And you can write any code that you want, right? So any statements that you want, statements. Until you hit another case, right? Or until you hit the end of the block, of course. So enough theory, let's do it more specifically. So let's say colors, favorite colors is an enum. And then you have, let's see, you have red, orange, and pink. Let's make it blue. I got nothing against pink, but blue. Let's do pink. Right? And now it should look like this. Let's say, what's your favorite color, Luca? Give me your favorite color. Let's store that. Nobody has a favorite color? Well, we'll use mine. So what? Oh, I only have 3 favorite colors, right? Red. Oh, somebody said green. Okay, then we'll define green here. I saw multiple greens. Okay, green. So if your favorite color is equal to case green, right? Print hooray, just like my Twitch viewers. If it's orange, you like basketball, eh? Right? And then let's say I don't want to handle red, people who like red, and I don't want to deal with people who like pink. Again, no offense, I love pink. So we can just have a default case, right? Which is just literally the word case. And then you say, you don't like green or orange. Weird. Okay? Somebody's asking about how do you fall through cases. We'll get to that very soon, I promise. I promise. Oh my god. Alright. Alright. So something I didn't mention earlier. Enums are namespaced, right? So this belongs to the favorite colors namespace, right? So favorite colors. There's a way to get rid of this and for it to still work, but that's unique. That's less basic. Oh, fine, I'll show you. You can just do that, and you import the enum namespace, and you can import struct namespaces, and you can import variables namespaces as well. You can import a live pointer and all of that, right? Anyway, let's try it again. Okay, here we go. Since my favorite color was green, or your favorite color was green, then it matched this part right here, right? Good to go. Now let's say if somebody hits green, or let's put it a different way. This is the question that somebody asked about fall through. If you want green and orange to have the same message, hooray, I love both these colors. Right? Oh, great, I got quoted. I don't want to deal with people like pink. I like pink. I really do. Oh, internet. The internet. Okay. Again, anybody who's tuning in, we're just covering the basics of the language because last time it seemed a little hard for some people who didn't know about Jai yet. So I'm just teaching the basics. All right. So if you want these two values, you want to make sure that you fall through and still print the same message. You have to say it explicitly. We don't fall through by default. We just don't, right? So you have to say through, the through directive. Right? And you know what? Let's say we are covering the color red. Red is nice, by the way. So let's say I hit the color green because my favorite color or your favorite color is green. Then the through directive will get you to orange, and then you'll print this message, right? Now, you would think that because you're falling through here, you're going to fall through everything. Let's see if that's true. If you noticed, it did not fall through to red. In other words, you have to fall through explicitly with a directive every single time. So if you want to fall through again, you have to say through here. And then you'll fall through to red is nice. And it'll stop there again, right? And now it actually did fall through. And you have no idea how much this has saved my bacon many times. So you cannot fall through by default, period. Okay, well, those are the basics. I've covered, let's go back to the presentation just to make sure I did cover everything. Where is the presentation? Oh, there is one last thing. I just went past the hour. So let's say this is actually pretty cool. You're gonna like this. So let's say that you want all of the colors handled. In other words, you want red handled, orange handled, green handled, and pink handled. Right now, we're handling is green, orange, and red. But the poor people who love pink are not handled, right? You can force that to happen by specifying complete right before the expression, right? Let's try it out. Remember, I'm not handling pink. Now look at this. This if was marked hashtag complete. And since I didn't handle pink, it didn't compile, right? So pink. And now it works, right? It works. Also very useful. Of course, you can't complete an integer. So you're using it for enums, right? Just for enums. So somebody's asking, what determines what's a compiler directive? Well, a compiler directive has a hashtag or a pound before the word, right? Internally, they all go through the same, code paths. We will have to get into the internals of a compiler, right? But a compiler has a workspace by default, even if you didn't create one, which has subsystems available, and they're all fairly independent from each other. So the workspace has, the type table packer, the bytecode runner, bytecode generator. It has the lexer, of course, and the parser, and they're all instances of that. So you can have multiple instances of these subsystems and hook into those and get stuff done, including processing directives and processing regular keywords, and it all goes to the same place. So that part of it makes sense, but we'll talk about that when we go into workspaces. So again, I think we're done with the basics. I'm gonna have to stop the stream, and next time we will talk about the first unique feature of the language, right? Which will be workspaces. And now, boy, I have a lot of fun stuff with workspaces. But yeah, we covered the basics. Let me just make sure. Yep, variables and pointers were accounted for. Procedures, structs, enums, and unions were accounted for. Again, just the basics, not everything, because structs can have procedures inside of them, functions inside of them, constructors and destructors that are not like C and C++ destructors. So I didn't cover that kind of thing, just the basics. And we covered simple statements, which was if statement and switch statement. Oh no! Oh. This is gonna be a long stream. And I already promised it was going to be like an hour for everybody. Okay, well, we have no choice. It's more important to teach everything than sticking to a schedule, right? Okay, so iteration, here we go. Great. Iteration. Where's the thing? Here you are. Okay. Vim. Okay. We know the deal. 14. There we go. So this is how while loops work, right? While you have some condition, execute the code after it, right? And that's all there is to it. But we can quickly show you a couple examples. So should I run my game, right? Remember, this is false by default. We can either initialize right away equals true, like this, or we can just do it after. Should run game equals true, and then while should run game equals true, do what you want to do. Again, this is a Boolean already, so we don't need this. And you're good to go. And then any valid expression can be here, right? So my result equals 100, that'll work. Again, you don't need parentheses. You don't need that at all. You're good to go. Now, for statements are a lot more interesting, right? So the basic syntax for a for statement is like this. And I will explain it carefully for you guys. Let's just print I, and let's make n 10, right? Let's compile this. And there we go. Now, what would you expect to see, right? In other words, I will take on the value all the way from 0 up to and including n, right? So it's not asymmetrical, right? It's you have symmetry in the range here. So if you want to actually do 0 through 9, it's n minus 1, right? That's different from C and C++. I got used to it very quickly after a few days, so 0 through 9, right? Now, you can omit the I if you want to, right? So let's omit the I. Okay, that'll work. But then, how do you access the index, the current index? Well, there's a name for that by default. If you didn't give it a name, like I, then you want to say IT index, right? Not even that. You can just say IT. We'll get to IT index in a bit. IT is enough. Make sure I didn't lie to you. Yep, it just works, right? Print it, right? So that's all well and good. Yep. Now, let's see. What if we have an array? So array, let's just use high scores again. High scores, you have 100. Oh, that's too much. You have 10 high scores, right? Let's just do 3 high scores. and we're gonna give some values to them. 5, 50, and 500, right? That's pretty cool. Now, if you want to iterate over each element, you can do it this way. For element, doesn't have to be element, it can be any name you want, right? But element is fine. Then the index, so that's 2 identifiers. That's going to be extracted from high scores, right? And now we can say array element, and then index is ba. There you go. Let me make sure that is true. Yep, there you go. Array element 5, index is 0, 50, 1, 500, 2, which is exactly what you see on the code. Okay. Real quick, element is a copy of the element of the array. It's a copy. Okay. So if you were to want to modify values and stuff, you have to take a pointer to it, right? But let's just quickly say that you can omit the index. So the index can be gone. And then you can actually access the index just by saying it index, right? And that'll work. See, it's still working, but we got rid of the index variable name, and now we're just using the one assigned by the compiler by default, it index. Can we get rid of element? Do I have takers? Who says we can get rid of element as well? And what name would it take? What name would it take? Let's look at B. No, unfortunately, time is running out. Oh, somebody said it'll be it. Okay. Yes, it would be. So if we get rid of this and we try to compile, it will complain, right? Because now element doesn't exist. So now we can just say it, right? So for high scores, for all the high scores, print it and print the index. And it works, right? People were asking about lambdas earlier. I would consider that I wouldn't consider that the basics, but you can definitely have print name, right? That's a function or procedure, and then you can say name lambda equals print name, right? And you're good to go. And now you can invoke the lambda and call print name through the lambda, or the this thing is that there's so much to that, right? That I want to pause and leave that for later. Now let's say you don't want a copy of the element of the array. You want the address of the element of the array, the address, right? Well, first of all, let's just quickly bring back element to make it easier, right? You can take a pointer to it by using the star, right? And that's it. It should still work. Giant undeclared. Oh, right. We're not using it anymore. Now let's print. Notice that the element is now a memory address. So we have to dereference it if we actually want to get access to it. Boom. Right? And now it's just back to normal. What if I don't want to say element? That's fine. Get rid of it. You can keep the star and you still have a pointer, right? So if you just print it, ah, ah, we have it, right? So we can dereference it. We can dereference it. We can dereference, comma, it, right? And you're good to go, right? I think we'll leave it at that. You can definitely instead of high scores is an array right now, right? Even though it's an array, you can use something else. You can use your own personal data structure, right? As long as you make iterators for it. You have to write some iterator procedures that will then, the compiler will then call behind the scenes for you to go through each element. But that's more advanced, and we'll leave that for later. So. I may not have time for more questions because it's been over. How long has it been? Ooh, an hour and 25 minutes. I'm done. I'm done. Until next Wednesday. Let me just read maybe one more questions. I have a for loop inside a for loop, and the element is named in the inner, but not in the outer loop. And if I use it in the inner loop, that's the outer loop's element. Let me read that again. Oh, you wanna know if it is available inside another scope. As long as that other scope, if it's a for loop and it's not using it, whether or not you have access to the it outside that for loop that is nested. How about we answer that next time? We can write it on the code and compile and see. So, yeah. All right, so thank you very much. I do appreciate it. Next week, I will try to answer some of the questions some people asked here. I couldn't get to all of them. I'm sorry, but I'd love to get through some more of them. And then we can get through the workspaces feature. So we can finally stop talking about the basics, and we can then touch on what I wanted to touch, which is Jai's unique features, starting with workspaces, right? So see you next week, 5 p.m. PST. If you wanna follow notifications, you can do it here, or just follow me on Twitch. Can we look forward to longer stream next week? It has to stay an hour for other folks. It's not fair for them. Bye.